Ever pondered the significance of calcium and magnesium in the lubricating oils used in your car's engine or automatic transmission? Well, let's take a moment to appreciate these unsung heroes of the mechanical world. These elements play dual roles, acting both as beneficial additives and potential contaminants in lubricating oils. As additives, they serve as detergents, keeping metal components clean and neutralizing acids formed in the oil. But their concentration levels can shift in line with trends in motor oil formulations. On the flip side, in environments like quarries and mines, they can enter the oils as contaminants, potentially leading to issues like oil foaming and impaired heat transfer. Their impact varies depending on the specific application, whether it's in automatic transmission fluids or engine oils. Understanding these roles is essential for maintaining the performance and longevity of mechanical systems. So let's dive deeper into these fascinating elements and their roles in lubricating oils. Calcium and magnesium as additives play a crucial role in the performance of lubricating oils. Dive into an engine or automatic transmission fluid, and you'll find a bustling world of elements. Two of these are calcium and magnesium. Their concentration levels typically range from 500 to 5,000 parts per million. However, in some new very low ash oils, these levels can be much lower, sometimes even near zero. It's like a bustling city where the population can vary drastically depending on the neighborhood. But what role do these elements play in lubricating oils? Well, think of them as the street cleaners of the oil world. They function primarily as detergents in engine oils, keeping hot metal components free of deposits. They also neutralize acids formed in the oil, contributing to the reserve alkalinity of engine oils. So they're not just cleaners, but also peacekeepers, maintaining harmony in the oil environment. Now let's take a look at the recent trends in motor oil formulations. Here we're seeing a shift, like a changing fashion trend. In SN Plus motor oils, for instance, there's a move towards more magnesium and less calcium. This adjustment is designed to tackle specific engine performance issues. It's like changing the ingredients in a recipe to get a better taste. So, in the grand scheme of things, these elements are not just additives. They are essential components that maintain the performance of your engine. Just like how a city needs its workers to function smoothly, an engine relies on these elements to run efficiently. But remember, while they play a beneficial role as additives, these elements can also become contaminants under certain conditions. And that leads us to the next part of our discussion, which we will cover in the following scene. As we can see, these elements are not just additives but essential components in maintaining the performance of your engine. While calcium and magnesium are beneficial as additives, they can also enter the oils as contaminants, impairing their performance. This is a tale of two elements, playing dual roles in the world of lubricating oils. Let's delve into the sources of contamination. Picture this, you're operating machinery in a quarry or a mine. Here, calcium and magnesium, along with other minerals, are abundant. They can easily hitch a ride on dust particles and find their way into your lubricating oils. For example, in mobile applications, magnesium can be found in road dust, often increasing along with calcium, particle count, and possibly silicon or aluminum. Now, what happens when these elements make an uninvited entry into our oils? Well, it's not a pretty picture. High levels of calcium and magnesium can lead to a range of issues. One of the primary concerns is oil foaming. You see, these elements can increase the air entrainment of the oil, leading to foam formation. This foam can compromise the oil's ability to lubricate effectively, causing increased wear on your machinery. But that's not all. The presence of these contaminants can also lead to a loss of the oil's lubricating quality. This means that the oil won't work as efficiently in reducing friction, potentially leading to overheating and increased wear and tear. Furthermore, calcium and magnesium can impair the oil's heat transfer capabilities. This could result in the oil not being able to cool your machinery components effectively, potentially leading to overheating and premature failure. So, while calcium and magnesium are beneficial as additives, when they enter lubricating oils as contaminants, they can wreak havoc on your machinery. This highlights the importance of regular oil analysis for effective monitoring of these elements. By understanding their roles, whether as beneficial additives or potential contaminants, you can better maintain the performance and longevity of your mechanical systems. So, while these elements are beneficial as additives, it's clear that as contaminants they present a very different story. Let's now look at how calcium and magnesium function in specific oils like automatic transmission fluids and engine oils. In automatic transmission fluids, these two elements are integral to the formulation. They play a crucial role in maintaining the performance of the fluid by keeping the hot metal components free of deposits and neutralizing the acids formed in the oil. Shifting gears to engine oils, calcium and magnesium serve a similar purpose. They act as detergents, contributing to the reserve alkalinity of the oil. This alkalinity is key to neutralizing the acids that can form in the oil, thus preventing potential engine damage. Recent trends in motor oil formulations like in SN Plus motor oils show a shift towards more magnesium and less calcium. This adjustment is made to address specific engine performance issues. Understanding the roles of calcium and magnesium in these specific oils can help us ensure the longevity of our mechanical systems. So what have we discovered about calcium and magnesium in lubricating oils? Well, we've delved into the fascinating world of lubricants and learned that calcium and magnesium play integral roles as both additives and contaminants. As additives, these elements primarily serve as detergents in engine oils, keeping hot metal components free of deposits and neutralizing acids. We've also noted that their concentration levels can vary significantly, from 500 to 5,000 ppm in engines and automatic transmission fluids. On the flip side, we've explored how calcium and magnesium can infiltrate lubricating oils as contaminants, potentially leading to issues such as oil foaming, loss of lubricating quality, and impaired heat transfer capabilities. In relation to specific oils, we've shared that automatic transmission fluids and engine oils often include these elements in their formulations. Remember, regular oil analysis is essential for effective monitoring of these elements and maintaining the performance and longevity of your mechanical systems.